Okay, the warm-up answer is on the board. Please take a moment, check first, and then ask your group if they got it. Ready? Go.
I got it right.
You guys hear Ronnie's question?
Yes.
Okay, this one just said graph, correct? Do you need to find the coordinates of J prime, K prime, L prime? No, it's only to help you, okay? So you do not have to find the coordinates of each. You can just know, I knew my translation's moving it down 3, and then I know I need to reflect it over the y-axis. If you're a visual person, you can visualize it. If you know how to do both, though, that is my recommendation, because you can go back and you can check yourself, right? But if you don't know how to do both, you only know how to do one, you better trust yourself completely in that one method, okay? So the red graph was shifted down 3 units from where the black graph is. You guys agree?
Yeah.
And then how did we get the blue one? How did we get the blue graph? What did we do? John?
You do the reflection with the y-axis.
Good. So what's changing?
The A is changing to negative.
Good. It goes from A comma B to what?
Negative A comma B.
Negative A comma B. Your y value stays the same. All that happens is whatever your x value was, it changes sign. Hayden, I'm waiting. What's up? So you're saying if we had negative 2 comma 0?
Yeah, that would change into 2, 0.
That would change into 2 comma 0. Yep.
All right.
Mm-hmm. Now what if it was 0 comma 2?
It'd stay like that.
It would stay like that, okay? Because is 0 positive or negative?
Neutral.
It's neither, okay? So changing the sign of a 0 does not change the coordinate. Excuse me, too much coffee. Yeah.
Why do you put the A comma B and to the left, to the right? Yeah, why do you do that?
This is a rule, okay? Do you remember the rules?
The actual rule?
No.
You're putting that.
I'm just putting that because look, all of your points, right? You'll notice that J prime to J double prime, do you see the only thing that changes was the x value changed from positive to negative? From K prime to K double prime, that negative 2 in the x coordinate became a positive 2. Do you see that, Cody?
Yeah.
So that's all that rule is telling you. It's showing you what to do for that coordinate, how you can change that coordinate to indicate a reflection. Okay? We Gucci on this one? All right. Today, guys, we're learning about something called rotations. Now, just a little summary, okay? So what are the 2 transformations we've learned so far? We just used them. Hayden? We will, I promise. Yeah, Alexis? Translations and reflections, okay? So we're learning rotations, and then we have a quiz on this Friday, okay? So we only need to know 3 transformations for the quiz. There's only 4 in total in this chapter, okay? But we need to know all 3 of these before we get to dilations and shrinks, okay? All right, so rotations. Guys, if I stand in this position and I rotate all the way around to face the opposite direction, how many degrees did I just rotate?
180.
180. Why?
Because you flip side.
Because look, did I just form a straight line with the 2 angles?
Yeah.
Ah, interesting, right? Did we learn that straight lines have 180 degrees? If I rotate from here all the way around and back to where I started, how many degrees? 360. Have you have you guys seen like skateboarders, how they rank like their tricks based on how far the board spins around? They're like, oh, they just did a 720, right? That's all related to the degrees that it rotated, okay? So if I go here and I rotate 90 degrees, oh, shoot, I gave you the answer. If I start here and I rotate like this, how many degrees?
90.
90, okay? So those are the big ones. 90, 180, 360, and there's one more, 270, okay? Now, let's relate that to a clock, okay? So if I'm at this clock and I start at like 12 o'clock, right? And I rotate to 3 o'clock, how many degrees? 90. If I start at 12 o'clock and I rotate to 6, 180. If I start at 12 and I rotate to 9, that's 270. If I start at 12 and rotate all the way around, I'm back to 360. Okay? Does that kind of make sense? Now, one thing that's a little bit different is we are going to be using something called a center of rotation. Okay? And that is the point in which you are rotating around. So for me, what did you guys remember when I was rotating? My center of rotation was myself, okay? My body. On the clock, what would be the center of rotation? What were we rotating about? Yeah.
That thing in the middle.
The middle of the clock, okay? On a graph, what are we going to be rotating about?
Point.
What point? 0, 0, okay? We will not rotate about any other point except for 0, 0, also known as the origin. Write that down, okay? We are going to be rotating, oops. Zero comma 0, aka our origin. Origin. Yes. Quickly. All right, now, how much I rotated, right, depended on the angle. Do you guys agree? So if I rotate 90, I'm rotating less than if I rotate 180, right? That is what we call now the angle of rotation. So that's going to tell us how much are we rotating this figure, okay? Now, if your point lies on the center of rotation, okay? So if my point was the center of this clock and I rotated it 90 degrees, where would my new point be?
180?
The same. Why?
Because it lies on the x-axis.
It lies in the middle, okay? If your point is on the center of rotation and you rotate 90 degrees, same thing. Do you remember when we did reflections and a point lied on the mirror? Did that point move after you reflected it? No. Same thing for the center of rotation. If your point lies on the center of rotation, it's not going to move when you rotate, okay? Do you guys understand that? Now, if it's any distance away from your center of rotation, it's going to move when you rotate, okay? Now, below it is an example of a 40-degree rotation about the point P, okay? So they drew a line up to point Q, and then they moved it 40 degrees, creating a 40-degree angle, and then they had Q prime, okay? Now, the big three that we're going to talk about are 90 degrees, 180, and 270, okay? And that's what we get to on the next slide, okay? So also what depends is your direction, okay? So have you guys noticed, like, how many of you have done, like, manual labor before? And, like, you've screwed something into a wall, right? Have you guys heard, like, righty-tighty, lefty-loosey, okay? Those are angles of rotation. So if you rotate from the top to the right, that is what we call clockwise, okay? And I'm going to abbreviate in this lesson as CW, okay? Clockwise. If you rotate from the top to the left, in other words, lefty-loosey, it's considered counterclockwise, which I will abbreviate CWW, okay? Now, this is very important. If the question does not tell you which way to rotate, you always rotate counterclockwise. So put a star next to counterclockwise. This is always used when not specified. So if it just says rotate 90 degrees, which direction are we going to rotate? Counterclockwise, okay? If it said rotate 90 degrees clockwise, are you going to rotate counterclockwise? No, but it'll have to say it. Wait, did I put CWW? Whoops. That should be CCW. CCW, excuse me. Let me erase that. CCW for counterclockwise. You guys understand that, right? The CC stands for counterclock, and then the W is for wise. So counterclockwise. Okay, questions so far? This is new stuff. Even my algebra peeps that I had last year, we have not seen this before, okay? So it's going to be a little bit foreign. Okay. Now, 2 slides from now. As always, there are rules, okay? There are rules to rotations. And the 3 that you must know are 90, 180, and 270, okay? Now, all 3 of these rotations are in what direction if it's not specified? Counterclockwise. Put a big CCW, okay? So if you rotate a figure 90 degrees about the origin, counterclockwise, if you had a point that was 3, 4, this is saying, okay, take your point, move the y value where x is and make it negative, and put the x value where the y is. If we had 3, 4, where would 3, 4 be after a 90-degree rotation? Bryson?
Down to the left. Right to the left. 1/4.
Okay, but what would be the new coordinates? Can you apply that rule?
Negative BA.
Negative BA, which if our point was 3, 4 to start with, what would be the new point?
1/2.
Nope. Yep.
Negative 4, 3.
Negative 4, 3.
Oh, I thought you meant like 3/4.
Oh, no. Okay, so rotations, that's a good assumption because like you can almost divide your graph into 4 quadrants, right? It is going to move into a different quadrant, okay? But what we care about are what are the new coordinates, okay? That's a good, I'm glad that you said that though, because that is, you're right. It is like kind of like a fourth. You're moving it a fourth away from the graph, okay? Rotating 180 degrees. Remember, 180 means rotate it completely to the other side, right? So that's saying whatever it was, just change both the x and the y to be negatives. What would 3, 4 then become? Negative 3, negative 4. Do not change the 4 and the 3. Do you guys see that? Don't flip them. And the last one, if we had 3, 4, if you rotate 270 degrees about the origin, counterclockwise, what's your new coordinate? 4, negative 3.
I have a question.
Yeah, go ahead.
If let's say, okay, for the last one,
Yeah.
3 was a negative, would you keep it as a negative?
Okay. Wait, for the last one.
Yeah, for the last one.
So let's do it again. Let's say it was 3, negative 3, 4, right? This would become 4, positive 3. Okay? Because you're technically adding a negative here, right, Sophia?
Yeah.
So it's negative 3, which becomes positive 3. Okay? Does that make sense?
Yeah.
Good question. Do we understand that, guys? So you're just changing the sign. You're not necessarily having to make it negative. If it was negative before, it's going to become a positive. Okay? Now, guys, this is super important. So please put your iPads face down and look at me. Okay? So if I start here on my clock, right? And I rotate counterclockwise, so against the clock, 90 degrees. What time am I at?
270.
What time?
Oh,
9 o'clock, right? 9 p.m.? Start here. How much would I have to rotate clockwise to be the same as a 90-degree angle counterclockwise? 270. So write this down. A rotation of 90 degrees counterclockwise is the same as 90 degrees clockwise. Okay? So 90 degrees CW is the same as 270 degrees counterclockwise. You guys with me so far? Yes. No? Who's saying no? Alexis, what's up?
I'm confused.
So, counterclockwise, right? Against the grain. 90 degrees. Do you agree I would get right here? This is a 90-degree angle. You have to rotate 270 to reach this same point if you want to go clockwise. You got it? Because they have to meet up here. We Gucci? Okay. Cody, you also had your hand up. You're good?
Yeah, no.
Okay. 180 degrees. If you rotate counterclockwise 180 degrees, what would be the same rotation clockwise? 180 degrees, right? Because regardless of which way you rotate, you're rotating all the way to the opposite side. Do you guys agree? That's the same degrees. So 180 degrees is going to be the same as 180 degrees clockwise, CW. And the last one, if you rotate 270, what's the equivalent clockwise?
90.
It's 90, okay?
I
Same
think you put the first one wrong.
as, oh, I did. This one's 90 degrees clockwise. Whoops. Guys, that first one should be 270. Thank you, Bryson. We all make mistakes. 270. 270 clockwise? I'll zoom in. I know that's hard to see. My bad. You guys all changed it, right? The first one says 270 clockwise?
So for a rotation for 270 is 90 and for 90 is 270?
Correct, depending on the direction in which you go. Now, the cool part is if you add both of those together, what's 90 plus 270?
360.
360. What's 180 plus 180?
360.
What's 270 and 90?
360.
360. So with 360 degrees, you end up back at the start, right? Just remember that. They should be related to add up to 360, okay? All right, look at the next example. Yeah, no, Because look, this last one is rotation 270 about the origin counterclockwise. B, comma, negative. My rules, okay? These three are gonna have to get memorized.
Hey, I know that, but how'd you get it though? I know where you got that, but.
Oh, where did that come from? Okay, so that's a really good question. Is just, okay, take your coordinate, reverse the order, so change the x and the y, and make your y value negative, right? So, but remember, if your point to begin with was already negative, so let's say it was like -3, comma, -3, right? Then you're reversing the order, so it's still -3, -3, but you have to make your b value, you have to add a negative to it. What's -3? It's +3. So that's how we're getting the 3, comma, -3. Does that make more sense? Okay. Any other questions, guys? What time is this one over? 55? Okay, we got some time. We're going to start with the quadrilateral RSTU, and then we're going to rotate it how many degrees? 270. What direction do I rotate this figure? Counterclockwise. How did you know?
Because it's unspecified.
It didn't say, okay? If it doesn't say, it's always counterclockwise, okay? So, write CCW. And before we do anything, let's write down the rule that we have to apply. So if my coordinates were A, comma, B, how am I changing my coordinates for a 270-degree rotation counterclockwise? Very good. It's -B, comma, A. I think it's B, comma, -A. I put -B, comma, A. Okay? A. Yeah. What's up, Hayden? Yes. Okay? I already made you guys a Quizlet, okay, to help you study. And it's posted on Canvas. So get started, okay? What's up?
You know how many questions are going to be on the quiz?
No, I don't. Okay. Let's plot the points. Where does R go? 3, 1, right? So here's R. Where's S go? 5, 1. So S is right here. T goes 5, -3. And U goes 2, -1. Oops. Did I mess up? Does that look right? No? Why not?
No, it's fine.
It's okay?
Yeah.
You guys got the same thing?
Yeah.
Okay. Now, all we care about right now are the coordinates. I'm going to show you the rotation afterwards. Okay. So, all we care about is where R prime will end up. Guys, where is R prime going to end up if we apply that transformation? 1, -3. So go 1, -3, and put R prime. S prime. 1, -5. So go 1, -5, put S prime. T prime. -3, -5. That was T prime. And U prime, the last one, peeps. -1, -2. Label them, people. That's very important, okay? Now, the visualization comes now. So I'm going to show you how this is a rotation of 270 counterclockwise about the origin, okay? And it starts by putting your center of rotation at the origin. So put a big, nice dot at 0, 0, 0. And draw a vector to whichever point you want to use. What point would you guys like to use? No. What point from your figure? Excuse me. Want to use U? Okay. So draw a vector to U. And then draw a vector to the image. What is the image of U? U prime. Now, what was my rotation? How many degrees? No, it wasn't 90. It was 270. In which direction? Whoa. Can you grab that one? That's right underneath your foot. Okay, so take your vector and draw an angle that's 270 degrees counterclockwise. So you guys agree this angle should be 270? Now, how we check that is not by that angle, but by the other one. I said rotating 270 counterclockwise was the same as rotating clockwise how many degrees? 90. Does this look like a 90-degree angle here? There's your visual, okay? So that's your visual. If that angle looks like this, if you get an angle that's like this, let's make it like really dramatic. If you get an angle that looks like this, does that angle look to be 90 degrees? You messed up, okay? You have to go back and do it until you get this sort of an angle where this looks like it's 90 degrees. Yeah?
Do you have to draw the vector?
No. If you trust your coordinates, you don't have to draw anything, okay? I want you guys in the beginning drawing the vectors so you can visualize it. Because it's one thing to be like, just trust the rule. You can trust the rule as much as you want, but if you can't visualize it, you're not going to be able to check if you got it right or wrong, okay? All right. Any questions on this one? Cody.
How'd you get B negative
A? So let's say you have a coordinate, right? That's over here. Do you agree? Like, I don't know, this green coordinate. And it's 3, 4. Do you agree?
Yeah.
Now, no, that's not 3, 4. It's 3, 3, right?
Yeah.
Okay. So if you want to move that coordinate to this quadrant, right? We're going to shift it over here. The rule for that we're doing here is we're basically rotating it 90 degrees and it ends up right here. Okay? Now, for 180, you just make both of them negative, and it's going to rotate further down to right here. Oops. Above a little bit more. And then if you rotate it again, 270, it changes to be right over here. In terms of how they came up with that rule, that's more of a proof. We're not going to get into that. And honestly, I don't really know. But you're asking like how did they get that rule from a 270-degree rotation? We can prove it by doing a bunch of points, but it's going to take a lot of time. Okay? What's up? Yes. Okay? I know that doesn't help. I'll do some research tonight and try to figure out like where it came from.
It's like B negative A. Isn't B negative A? Wouldn't that be like a positive and then a negative?
Oh, okay. Let's try another one. This is a composition because it's two transformations.
What is composition?
2 transformations or more, okay? So, what kind of transformations do we have? A reflection and a rotation. Very good, okay? Which one comes first? The reflection, and then we do the rotation. Make sure you're following the order that it's given in, okay? So, take your points, 1, -3. That's going to be my R. My S is at 2, -6. RS. Okay, do you guys remember how to reflect something over the y-axis? Ronnie?
You change the first to a negative.
Good. So it goes from A, B to what?
Negative
Negative A comma B. So my R prime is what? Negative 1, negative 3. Let's plot that. Here's R prime. And then my S prime? Negative 2, negative 6. Visualize it. If this is my mirror, is R prime and S prime the mirror image of R and S? Yes. Okay? You need to be able to visualize it. Do you see the difference, Benji?
Yeah.
Being able to visualize it is a good check for you. Alexis? No, that's for a rotation. We're not on the rotation yet. Okay? Now, the rotation 90 degrees about the origin. First off, which direction am I rotating? Counterclockwise, okay? What is the rule for 90 degrees counterclockwise rotation? Negative B, comma, A. Yeah?
Wait, is that rule the same for counter, like clockwise?
This is the rule for counterclockwise.
No, for clockwise.
For 90 degrees clockwise? No. 90 degrees clockwise is the same as what counterclockwise? 270. So you would follow the rules for 270 counterclockwise. Do you understand that now? Okay. So change my coordinates. What's R double prime, peeps? 3, negative 1. What's S double prime? 6, comma, negative 2. Go ahead, Hayden. Yes, you always use your image and then rotate it from the image, okay? You don't use the original coordinates. Good question, okay? All right, 3, negative 1 is right here, and 6, negative 2 is right here. R double prime, S double prime. How can we check it? Use the vectors, okay? Start at 0, 0. That's where we're rotating about. And draw a vector to what letter? To R. Then to what? R prime. That does not look like 90 degrees. Oh, draw it to the other one? So draw it from here to here. That also doesn't look like 90. What's going on, people? Ronnie? What's wrong?
The blue point.
Good. No, it's not wrong. These points are actually right. Mario? Good. Red to blue. Because which, do you guys see, the red was after what? The reflection. And then we rotated. Do you guys understand that? So you have to go from R prime to R double prime. Does that make a 90 degree angle now? Yes, and this is rotated counterclockwise. Do you guys see it now? So this is 90 degrees. Yes. Why do you have to do that? You do not have to do that, Hayden. Okay? Why are we doing this for ourselves? To check it, okay? This is a good check. What's up?
So how do you know when you draw the vector to the regular one or to both images?
Okay, when did the rotation happen? First or second?
Oh, the second.
Second, right? So you have to go from the image to the final image because the rotation was the last thing that we did. You agree? So between that one and that one, there should be a rotation.
So if the rotation's first, you just put...
Correct. It would go from R to R prime. Good. Okay? Good. Hayden, what's up? Okay. So if the rotation's second, right? That's the second transformation. You're going to end up at R double prime, but you must start at R prime, not from R. Got it? Because what happened between R and R prime, guys? What happened between R and R prime?
A reflection.
A reflection, okay?
Yeah.
Wait, so this one was 90 degrees?
Yes. We're Gucci?
Yes.
Okay. Rotational symmetry. This is the last thing, guys, okay? Rotational symmetry. What did it mean for symmetry in the last lesson?
Like you could cut in like half.
Yeah, and it was the same on both sides, right? Rotational symmetry is if you can rotate your figure a certain amount of degrees and it looks the exact same as you started, okay? So this figure, do you guys agree? If it's rotated 45 degrees, it does not look the exact same? It's kind of like diagonal. How much do they have to rotate for it to look the exact same? 90. Do you guys see that? So it has a rotational symmetry of 90 degrees and 180 because all three of these are the exact same figure. Do you guys see it? Okay. Now, you only count it if you're rotating less than or equal to 180 degrees. Because if you rotate any figure 360, it will always look the same. Right? Because any figure rotated 360 degrees is just the original figure. Do you guys agree? Yeah. So it hasn't changed at all. So it has to be less than or equal to 180. Take a look at these figures, okay? And I want you to lasso the figure, and I want you to start to turn it. Okay?
Wait, what's the word?
Use the lasso button. How do I turn this? If I rotate it 90 degrees, is my figure the same? Are these two the same? No, they're not, okay? What's different? Well, the jagged edge is pointing up. Do you guys see that? Rotated another 90. How many degrees have I rotated it now? 180. Is it the same? So what's my rotational symmetry? So it has rotational symmetry. Symmetry of 180 degrees. If we rotated it 360, would it also have rotational symmetry of 360? Yes, we don't include it though because 360 is larger than what? 180, okay? What about an octagon? It is, okay? So, but we have to figure out, okay, how much are we rotating it? So you can grab this octagon, right? And you can rotate it so that this becomes the base. And we have the same exact octagon. Do you guys agree? But how much did we just rotate it? We'll finish this one tomorrow, okay? Okay, so this octagon, every time we rotate it where a new side becomes either the top or the base. So for example, we're starting with this side being the top or the base. When we rotate it so that this one's the top and this one's the base, so we rotated it counterclockwise, then we have to figure out, okay, how many times can we rotate it so that it ends up in the same position, so it has rotational symmetry. Well, there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 sides. So if there's 8 sides, every time we rotate it to a different side, we have rotational symmetry. So rotating it all the way back around to the very beginning would be 360 degrees. We're going to divide that by the number of sides or the number of times it has rotational symmetry, which is 8. If we take 360 divided by 8, let's see what we get. So 360 divided by 8. 8 goes into 36 4 times, we get 32. And then we get a 4 remainder, bring down your 0. 8 goes into 45 times. So it's 45 degrees of rotational symmetry, okay? So now we have to find all the angles that have rotational symmetry up until 180. So 45 is our first one. Add 45, you get 90. Add 45, you get 135. And then add 45, you get 180, okay? So there's 4 angles where it has rotational symmetry. We do not include the angles that are above 180. And how I got these angles was I took my original rotation of symmetry and I added 45 each time. I added 45. Okay, now this trapezoid over here, okay, it does not have rotational symmetry, okay? Because the only way that this long side will end, like, that it'll be symmetrical is if it ends right back up, up on top. When it rotates to where this longer side is on the bottom, it does not have symmetry because it's not the same figure, okay? The smaller side is on top. So this one has no rotational symmetry. And that's it.